All right, let's get right into it. If you're studying for an AWS certification, you know Amazon EMR is a topic you absolutely have to nail. So in this explainer, we're going to cut right to the chase and focus on the must-know, high-yield facts that are almost guaranteed to pop up on your exam. Let's do this.
Here's our game plan. We're going to fly through 5 key areas. We'll kick things off with the basics, then get into the super important storage decision between HDFS and EMRFS. After that, we'll tackle security, talk about making your clusters highly available, and wrap it all up with how to monitor and fix things when they break.
Okay, first up, EMR fundamentals. Look, before you can even think about the tricky scenario questions on the exam, you got to have a rock-solid grip on what EMR actually is and, why you'd even use it.
So what is EMR? At its core, it's basically AWS's way of taking the headache out of big data. Imagine trying to set up a whole Hadoop or Spark cluster from scratch. It's a ton of work, right? Well, EMR handles all that heavy lifting for you, so instead of messing with infrastructure, you get to focus on what matters, analyzing your data. The key phrase to remember for the exam, Managed Cluster Platform.
Now this is super important. EMR doesn't exist in a vacuum. It's woven deep into the AWS ecosystem, and you can bet the exam will test you on this. The cluster nodes, those are just EC2 instances. The data you're processing, that's usually sitting in S3. Permissions, handled by IAM. Monitoring, that's CloudWatch. And the whole thing lives inside your VPC. You've got to know how these pieces fit together.
All right, on to our second topic, and this one's a big one, storage. This is probably one of the most critical decisions you'll make with EMR, and it is absolutely a hot topic for the exam. It really all boils down to a single question.
Where does your data live? Seriously, think about it. Is it stuck to your cluster, so when the cluster goes, the data goes? Or does it live on its own, completely separate? The answer to that question is what decides whether you're using HDFS or EMRFS. Let's break it down.
Okay, check out this comparison because it makes it crystal clear. HDFS is ephemeral. It lives on the EC2 instances that make up your cluster. You terminate that cluster, and poof, your data is gone. It's really fast, so it's great for temporary stuff, like intermediate data during a job. But EMRFS, that's the game changer. It uses S3 on the back end. This means your data is persistent. It's totally decoupled. You can shut your cluster down, and your data is perfectly safe over an S3.
So for the exam, you have to know why EMRFS is so powerful. Because you're decoupling compute and storage, you get this incredible flexibility. You can spin up a massive cluster for a really intense job and then just shut it down when you're done to save a ton of money. And your data? It's totally fine, sitting right there in S3. This whole idea of using temporary, job-specific clusters is a massive cost saver and a huge exam concept.
Okay, let's switch gears to Section 3, Security and IAM Roles. You know the drill with AWS. Security is always job zero, and EMR is no different. You've got to know how to lock things down, and it all starts with understanding its 2 main IAM roles.
Now listen up, because this is a classic exam trap. People mix these two up all the time. First, you have the EMR_default role. Think of this as the role for the EMR service itself. It lets EMR do things for you, like launching EC2 instances. Then you have the EMR EC2 default role. This one is an EC2 instance profile. It gets attached to the actual instances in your cluster, and it gives the applications running on those instances permission to do things, like read data from an S3 bucket. Service versus application. Don't get them confused.
Here's a super practical scenario you might see. How to get SSH access to your cluster. It's all about security groups. You find the primary node security group and you add an inbound rule for SSH on port 22. But, and I can't stress this enough, for the exam you have to know to set the source to a specific, trusted IP. Never, ever, ever leave it open to the world with 0000/0. That's an instant wrong answer.
Okay, moving on to Section 4. High availability. See, a normal EMR cluster has just one primary node, which is a classic single point of failure. If that node goes down, your whole cluster is in trouble. For anything important, you need to plan for failure, and that's where HA clusters come in.
So, what's the magic number for an EMR high availability cluster? It's 3. That's it. For the exam, just burn this number into your brain. If you want to survive a primary node failure, you need a cluster with 3 primary nodes. Simple as that.
Now here's where it gets a little tricky. When a primary node actually fails, the EMR step might get marked as failed.
But, and here's the catch, the actual application running underneath might be fine because Yarn automatically fails over. So, your action on failure setting becomes really important. You'll want to use continue or cancel and wait. But whatever you do, for the love of all things cloud, do not use terminate cluster. I mean, that just completely defeats the entire purpose of setting up an HA cluster in the first place.
All right, our last section, number 5, monitoring and troubleshooting. Sooner or later, something's going to go wrong with your cluster. How do you figure it out? Knowing what tools you have is absolutely essential.
Your troubleshooting toolkit has 3 main things. Your first stop should always be the error details in the console. It gives you a quick look at what happened. If you need to dig deeper, then your best friend is the log files, which EMR conveniently archives for you in S3. And if it seems like a performance problem, you'll want to jump into CloudWatch to check out metrics like CPU, memory, and how your jobs are progressing.
To really troubleshoot well, you have to understand what an EMR step is. It's the basic unit of work. Think of your cluster as the factory, and a step is just one task on the assembly line. You just submit a sequence of these steps, like a Spark job, then a Hive query, to get your overall job done.
And every step goes through this life cycle. It starts as pending, then goes to running, and hopefully it ends up as completed. But what the exam loves to ask about is failure. You need to know that, by default, if one step in your sequence fails, all the steps after it are automatically canceled. They won't even try to run. You can change this, but you have to know what the default is.
So, if you only remember one thing from this entire explainer, let it be this. The real power of EMR, the modern way of using it, is all about separating your compute from your storage. You use temporary clusters to do the work, while your valuable data lives safely and persistently in Amazon S3. That is the whole philosophy behind EMR-FS.
So I'll leave you with a question to really think about. Now that you get this idea of decoupling, how does that change how you design a system? How could you schedule jobs to spin up a giant, powerful cluster for just an hour to crunch some numbers, and then have it just disappear, knowing your data is safe and your bill is way, way smaller? When you start thinking like that, you're ready for the exam. Good luck.